Okay, hi, Assalamualaikum. We are part 4 from group 11. We want to introduce for radar system in our group presentation PHY260. And this is our team members. Okay, first we start with introduction. What is radar system and how it works? Radar system is a detection system that uses radio waves to identify the presence, location and movement of the object. It works by transmitting radio waves and analyzing the reflected signals, which is echoes, from objects in its range. This allows radars to see through conditions that may hinder other sensors like darkness, fog, or rain. There is a various application of radar system, which is first we have aviation, maritime navigation, weather forecasting, defense, and traffic control, which is we will introduce in this presentation. Okay, first we have aviation. What is principle of radar system that we have in aviation? In aviation, radar system operate on the principle of radio wave reflection. First, we have transmission and reflection. Radar system emit short bursts of electromagnetic energy, typically microwaves, in a narrow beam. When these waves encounter an object like an aircraft, they are reflected back towards the radar system. 2. Doppler effect, which is a velocity measurement. Some radar systems also utilize the Doppler effect to determine the target's velocity. The Doppler effect causes a change in the frequency of the reflected signal if the target is moving relative to the radar. An approaching target will cause a higher frequency, while a receding target will cause a lower frequency. Then we have some various applications of radar in aviation. First, we use for air traffic control, which is used for surveillance of aircraft in flight, near airports and during approach and landing. Second, we have for weather detection. Aircraft radar can detect weather information like storms and turbulence. Then we have for navigations. Radar can be used to map terrain and assist with navigation, especially in areas with limited visibility. Then lastly, we have for search and rescue, which is radar can help locate aircrafts or vessels in distress.
Next, I will talk about maritime navigation. Firstly, we have basic principles of radar use in navigation. Radar use radio waves that are reflected by many objects, including ships, islands, buoys, and shorelines. The radar system detects this reflection again and displays information about the object's location and distance. Next, we have radar function in ship. To detecting impediment or other ship, particularly in low visibility condition, for example, fog, night, storm, assisting in determining the relative position of other ships so that collision can be avoided. Navigating near ports or limited areas with heavy maritime traffic. Next, we have type of radar used in ships. Firstly, we have S-band radar, which is higher frequency, high resolution, shorter range. Next, we have S-band radar that lower frequency, greater stability in inclement weather, and longer range. Next, we have example of rear application. Firstly, we have cargo ship that use radar to navigate through congested location like the Strait of Malacca, and automatic radar system which is ARPA or automatic radar plotting aid that track objects automatically. Lastly, we have advantage of radar in navigation. Firstly, we have increased navigational safety, lower risk of collision, and can be utilized at any time or day or night regardless of weather.
Weather forecasting. The definition of weather forecasting is process of the predicting of the state of the atmosphere at the specific location for the future times. It involves analyzing current weather condition and using a scientific method and technology to estimate how the weather will change over the course of hour, day, or even a week. In simple terms, weather forecasting helps us to know whether it will rain tomorrow, how hot or cool it will be, and whether there will be strong wind or storm. So this is type of weather radar. First, dropper radar. Dropper radar is used to detect the speed and direction of moving weather elements like raindrop and wind. It's worked using a Doppler effect and is very helpful in storm detection and issuing tornado warning. Second, we have S-band radar. S-band radar operated with a long wavelength around 10 cm, allowing it to scan far distance and through heavy rainfall. It is mainly used by nation weather service for monitoring large weather systems like hurricane and strong thunderstorm. Third, we have X-band radar. X-band radar has a short wavelength around 3 cm, which is give high resolution weather image, but is only work at a short range. It is often used in urban area, research study, or airport to observe a local weather with a great detail. Fourth, we have C-band radar. C-band radar used in a medium wavelength around 5 cm. giving a good balance between distance and image quality. So, how the radar work? First, sending a radio wave. The radar system sends out short pulse of radio wave, which is microwave, into the atmosphere using an antenna. Second, hitting the precipitation. This radio wave travels through the air until they hit object like raindrop, snowflake, hazel, or a dust. Third, anchor reflection. When the wave hit this particle, they bounce back reflect towards the radar antenna as anchors. 4. Retrieve the anchor. The radar antenna retrieves this return signal. 5. Measuring time and intensity. The radar calculates how far the precipitation is by measuring the time it takes for the anchor to return. 6. Data processing and display. The radar system processes the data to create image or map showing where the precipitation is, how much there is, and sometimes its motion.
The defense in radar system. Radar systems are crucial for defense, providing early warning, tracking, and targeting capabilities against aerial and ground threats. They utilize radio waves to detect and locate objects, enabling timely response and effective countermeasures. This is also widely used in military defense. Type of radar system used in defenses is an early warning systems. Long-range radar systems are used to detect enemy aircraft, missiles, and drones while they are still far from the target area. This provides valuable time for defense forces to prepare scramble interceptors or activate countermeasures. For example, is over-the-horizon radar that can detect objects thousands of kilometers away. Next, we have target tracking. Radar provides precise target location, speed, and trajectory data for weapon system, ensures accuracy of guided missiles, artillery shells, and other smart firearms. For example, is fire control radars on fighter jets locked onto targets for missiles engagement.
Next, we go to the principle of radar operation. Radar system work based on a simple but powerful principle involving radio wave. First, the radar transmits a radio wave from an antenna to the target area. For example, a road where a vehicle is moving. When the wave hit an object, like a car or a truck, they bounce back. This is called reflection. The radar then receives the reflected wave using a built-in receiver. After that, the system analyzes the signal. It calculates the distance to the object by measuring the time it took for the wave to travel to the object and back. It also uses the Doppler effect, a change in frequency of the reflected wave, to determine the speed of moving vehicles. So, in short, radar system detect both the location and the speed of object using radio wave. That's how they help monitor traffic and control speed on road. Next, we go to the application of radar in traffic control. First, we have speed enforcement. Law enforcement agencies widely use radar technology to measure vehicle speed with high accuracy. Radar guns enable officers to detect speed violation, while automated radar systems, such as those integrated into speed cameras, can record speeding vehicles and automatically issue fines. This contributes to enhanced road safety and compliance with traffic law. Second, we have traffic flow monitoring. Radar sensors are installed along highway and at intersections to monitor real-time traffic conditions. This sensor collects data on traffic density, the number of vehicles passing through, vehicle classifications such as cars, trucks, or motorcycles. This information is transmitted to traffic management center, where it is used to analyze traffic flow and optimize road usage. Then we have adaptive traffic signal. The radar system play a crucial role in intelligent traffic signal control by detecting the presence and movement of vehicles at intersection. Radar allows traffic light to adjust their timing automatically. This dynamic adjustment help reduce traffic congestion, minimize waiting time, and improve overall traffic efficiency. Lastly, we have collision avoidance system. In the field of smart transportation and autonomous driving, radar is essential for enhancing safety. This system detects nearby vehicles, pedestrians, and other obstacles. By providing real-time distance and speed information, radar enables vehicles to react appropriately and avoid potential collision.
Lastly, conclusions. Radar technology is an essential part of modern life, with wide-ranging application in aviation, maritime navigation, weather forecasting, defense, and traffic control. Its ability to detect and track objects in various conditions ensures safety, security, and efficiency. As radar systems continue to evolve through innovation like phased array radar, Doppler radar, and autonomous vehicle application, they will remain critical tools across both civilian and military sectors well into the future.